All right, welcome back. This is question ID 2876. It's from Thermodynamics, the processes part of thermodynamics. The processes section is the one that concentrates on condensate subcooling or condensate depression and isenthalpic expansion of leakage through a throttle valve. We're in a TMI problem. All right, those are the two types of problems in the test bank for this particular section in thermodynamics. So P2876, it's a good problem. It's one we're going to have to think about, and maybe I'll show you some things you hadn't quite thought about. Make these problems a little bit easier for you. Make your understanding of isenthalpic expansion even greater than it already is. First thing we do when we look at problems, or we look at numbers, right? So right here with the numbers, we got 1,000, 35, 281, 0, 100, 0.1, and 100. Then we look at their units. 1,000 cubic feet, 281 degrees Fahrenheit, 35 psig. Whoa! Now I got an alarm, right? So I'm going to write right here 35 psig. Psi is higher. That's an easy way to remember it. Just add 15 psi to psig to get psia. So we're going to call that 50 psia. So we're going to get fooled there. 100% quality. All right, good. Dry steam. 0% quality. Wet water. And what was the other one? 0.1% of design flow. What's up with that? I don't know. Why is he telling me that? 100 pounds mass. 100 pounds mass. All right, cool. Now we can get to work on reading the problem, solving a problem. Oh, I like blue. All right, refer to the drawing of two 100 cubic foot pressure vessels with installed relief valves. So there they are. Relief valve, not safety valve. One's half full of water and has steam. One's full of water. Okay. Both vessels are in saturated conditions at 281 degrees and approximately 50 psia. Vessel X-ray is completely filled with saturated water. And yeah, that's vessel X-ray. Vessel Yankee contains 1/2 saturated steam at 100% quality. 1/2 saturated water at 0% quality about volume. Okay. And that is vessel Yankee, so that makes sense. Both vessels are protected by identical relief valves. So identical relief valves. That's good. If both relief valves begin to leak at a rate of 0.1% of design flow. I'm not sure that means anything other than they're both leaking at the same rate. The higher temperature fluid will initially be leaving the relief valve of vessel blank, and 100 pounds mass of fluid is released through both relief valves. The larger pressure decrease. All right, cool. So this is going to be a good exercise in using the steam tables. So first, I like to write down we're at 50 psia, and we're at 50 psia. We're going to call this atmosphere. That's going to be 15 psia. That's going to be true for this, both of them, since they're right next to each other. First off, we got to get a handle on what our enthalpies are. Enthalpies are going to tell us how many BTUs it takes to open up to raise 1 pound of water 1 degree Fahrenheit. All right, so first thing I want to know is pressure at 50 psia. I want to know the T saturation temperature at 50 psia. So we look at table 3, because table 3 is the best table. It's the easiest one to read. And on page 16, you look at 50 psia, you get saturation temperature of 280.99 degrees Fahrenheit. Now the enthalpy there at 50 pounds of water, the HF is 250.23 BTUs per pound mass. And the Hg at 50 pound SIA is going to be equal to 1174.2 BTUs per pound mass. So that right there should tell you that you're going to have a hotter tailpiece temperature on the steam side. So steam leaking is hotter than water leaking because it has higher enthalpy. All right, let's prove that, right? So we can all know that isenthalpic expansion keeps the enthalpy the same because that's why it's named isenthalpic expansion. So we've got 250 here, 1174 here. So now you got to find, sorry about that, the state of the fluid at 15 psi atmosphere. And the way you find the state of the fluid is you find the subcooled or the saturated liquid enthalpy and the saturated steam enthalpy at that pressure. So if you look on table 3, since it's the best table, you'll know that at 15 psi, so pressure equals 15 psi, you have 181.18 BTUs per pound mass for saturated water enthalpy and 1150.7 BTUs per pound mass for saturated steam. So since on the low end we have 181.18 and on the high end we have 1150.7, and we know this enthalpy for tank X-ray is between those two numbers, we can say that tank X-ray is leaving as a as wet steam. And the temperature of that wet steam is going to be saturation temperature at 15 psia, also known as 212 degrees. So we're going to have 250 BTUs, and that's at 212 degrees Fahrenheit. So we got 1174 BTUs per pound mass escaping from valve Yankee. 1174 is bigger than the enthalpy for saturated steam at 15 pounds. So that right there tells us that Yankee is hotter. So Yankee steam, the leaking stuff from Yankee, is going to be superheated. And it's going to be so superheated that it is more than 240 degrees Fahrenheit. So the HF for 15 pounds, 240 degrees Fahrenheit, remember we're superheated, is going to be 1163.9 BTUs per pound mass. The HG here, for 15 psia at 280 degrees Fahrenheit is going to be 1183.1. This is all off table 3, page 15. BTUs per pound mass. And we have 1174 escaping. We know that we're going to be superheated somewhere in a range of 240 to 280. Now we could calculate that with interpolation, but why do that? We don't have to. All right, now, so I want vessel Yankee here. So we can cross off alpha, cross off Bravo, because X-ray is not hotter than Yankee. Yankee's hotter than X-ray. All right. If 100 pounds mass of liquid is released through both relief valves, larger pressure decrease will occur in vessel. So to get the larger pressure decrease, I'm going to talk about red right now. Larger pressure decrease. All right, so we're at 50 pounds, right? So pressure equals 50 psia. All right. How fast, if 100 pounds mass comes out of here and 100 pounds mass comes out of here, what's the volume that this space is going to lose? That's the way I want you to think of that. How the pressure drop happens is what volume is this space going to lose? So we have a specific volume for 50 pounds saturated water, right? So we call that the VF at 50 pounds, and that is going to be 0.01 1.7268 cubic feet per pound mass. The VG, the saturated steam specific volume, is going to be 8.5171. 8.5171. I'm getting that off table 3 because it's the best table in the steam tables. And it's on page 16. And that is cubic feet per pound mass. So the problem tells us that 100 cubic pounds mass of liquid escaped. All right, so the volume that escaped from X-ray is going to be 1.7268 cubic feet, and the volume from Yankee is going to be 851.71 cubic feet. All right, think about that. So 851.71 cubic feet. Yeah, some of this is going to flash to steam, but it's going to take a huge pressure drop to get enough of it to flash steam, and none of it's going to come back. 100 pounds mass of water is much, much smaller, on the order 800 times smaller, it looks like, than 100 pounds mass of steam. So 851 cubic feet missing from this, and 1.7268 missing from X-ray. So the larger pressure drop is definitely going to be in Yankee. So I hope this helps, and I hope you enjoyed this problem. I know I did. So take care. We'll see you next time.